Hello, welcome to Astronautics for Exploits. This is Dr. Ayenshola Ogundele. Lunar exploration present missions for better understanding of solar system evolution and human existence in the universe. The focus points are present lunar exploration missions and list of present lunar exploration missions. In 1640, A World in the Moon, written by John Wilkins and classified as the first novel that gave the necessary preconditions for a voyage to the moon, gave the proof that the moon was an inhabitable planet which might be reached via some sort of aerial carriage. This in turn led to many innovative ideas that aided human physical exploration of the moon. In 1901, The First Man in the Moon, written by Wells, illustrated how a spaceship gets to the moon with the aid of Cavorite, a material which shoots out gravity. The lessons learned from the further science fictions and past lunar endeavors are the driving force behind the present lunar exploration missions. The lunar exploration present missions being undertaken to study the Earth's natural satellite, the moon, is aimed at extending the sphere of human life into space and creating a sustainable world. Examples of the ongoing lunar exploration present missions are SLIM, Chandrayaan-3, Chandrayaan-5, KPLO, Chandrayaan-2, Capstone, Chandrayaan-4, and Yutu-2, Lunar Reconnaissance Orbital, and a host of others. The Smart Lander for Investigating Moon is aimed at accelerating the study of the moon and planets using lighter exploration systems and to demonstrate accurate lunar landing techniques embodied in a small explorer. Present lunar exploration missions. Presently, in continuation of human exploration of the moon, numerous space missions are being undertaken to study Earth's natural satellite. Some of the ongoing missions are SLIM, Chandrayaan-3, Chandrayaan-5, KPLO, Chandrayaan-2, Lunar Reconnaissance, and a host of others. Artemis probes in lunar orbit is shown in this picture. List of present lunar exploration missions are SLIM, Chandrayaan-3, KPLO, Lunar Reconnaissance Orbital, Chandrayaan-4 and Yutu, Capstone, and Chandrayaan-5, and Chandrayaan-2. SLIM, Smart Lander for Investigating Moon, is a lunar lander mission of the Japan Aerospace Exploration Agency. First lunar service mission. On 6 September 2023, Russia, the X-ray imaging and spectroscopy mission, Space Telescope, SLIM, Russia, was successfully launched and SLIM separated from it later that day. On October 1, 2023, SLIM executed its translunar orbit injection burns. The lander successfully entered lunar orbit on 25 December 2023. Japan's SLIM spacecraft that achieved precision moon landing is shown in this picture. The purpose of SLIM was to demonstrate precision lunar landing. During its descent, the lander recognized lunar craters by applying technology from facial recognition systems and determined its current location from utilizing observation data collected by the Selene Lunar Orbital mission. The aim was to soft land with an accuracy range of 100 meters. SLIM lunar lander, as seen by Zoroki robot on the moon, is shown in this picture. SLIM has innovative navigation and landing systems. The experimental mission was proof of concept of a lightweight, accurate moon landing spacecraft. Instead of making large braking burn made by most moon-bound spacecraft, SLIM made a lunar flyby, imaging the moon on October 4th on its way past. SLIM's smart fuel-conserving trajectory saw it fly out into deep space on a long looping orbit that brought it back close to the moon at the end of December. An artist's impression of Japan's SLIM spacecraft deploying its Lunar Excursion Vehicle 1 is shown in this picture. Chandrayaan-3 is the third mission in the Chandrayaan program, a series of lunar exploration missions developed by the Indian Space Research Organization. The mission consists of a lunar lander Vikram and a lunar rover program. Chandrayaan-3 was launched on 14 July 2023 and the spacecraft entered lunar orbit on 5 August. The lander touched down near the lunar South Pole, making India the fourth country to successfully land on the moon and the first to do so near the lunar South Pole. Chandrayaan-3 lander with its rover inside is shown in this picture. Chandrayaan-3 mission objectives are engineering and implementation of a lander to land safely and softly on the surface of the moon, observing and demonstrating the rover's driving capabilities on the moon, and conducting and observing experiments on the materials available on the lunar surface to better understand the composition of the moon. Illustration of the Chandrayaan-3's propulsion module in lunar orbit is shown in this picture. Chandrayaan-5 is China's first lunar sample return mission. It was launched on 23 November 2020. An illustration of the docking operation between Chandrayaan-5's ascendant and re-entry capsule is shown in this picture. Chandrayaan-5 mission components included lander, which landed on the lunar surface after separating from the orbital, installed with a drill and a scooping device. The ascender is on the top of the lander. Ascender, after sampling, the lunar samples were transported to a container within the ascender. An orbital, after the samples were transported from the ascender to the orbital, left lunar orbit and spent approximately 4.5 days flying back to the Earth orbit, and the returner performed a skip re-entry to bounce off the atmosphere before formal re-entry. Illustration of Chandrayaan-5 probe separating from the launcher is shown in this picture. Korea Pathfinder Lunar Orbiter is South Korea's first lunar orbiter, and ground control infrastructure and technology demonstrators. The orbiter will also be tasked with surveying lunar resources such as water ice, uranium, helium-3, silicon and aluminum, and produce a topographic map to help select future lunar landing sites. KPLO mission was launched on 4 August 2022 on the Falcon 9 Block 5 launch vehicle and was inserted into orbit around the moon on 16 December 2022. Korea Pathfinder Lunar Orbiter is shown in this picture. The main objectives of KPLO are the development of critical technologies for lunar exploration, production of a topographic map for support to select future lunar landing sites, and to survey lunar resources such as water, ice, uranium, helium-3, silicon and aluminum, and development and validation of new space technologies. Artist's concept of South Korea's first robotic lunar orbiter in space is shown in this picture. Chandrayaan-2 is the second lunar exploration mission developed by the Indian Space Research after Chandrayaan-1. It consists of a lunar orbiter and formerly included the Vikram lander and the Pragyan rover. Illustration of Chandrayaan-2 is shown in this picture. Chandrayaan-2 scientific objectives are to study lunar topography, mineralogy, elemental abundance, the lunar exosphere and signature, and to study water ice and to map the lunar surface. Vikram lander mounted on top of orbital inside clean room is shown in this picture. Capstone is a lunar orbiter designed to test and verify the calculated orbital stability planned for the Lunar Gateway space station. The spacecraft is a 12-unit CubeSat that will also test a navigation system that will measure its position relative to NASA's Lunar Reconnaissance Orbiter. It was launched on 28 June 2022, arrived in lunar orbit on 14 November 2022, and was scheduled on orbit for 6 months. Illustration of the cislunar autonomous positioning system technology is shown in this picture. Chang'e-4 and Yutu-2. Chang'e-4 is a robotic spacecraft mission in the Chinese Lunar Exploration Program It contains U-2 rover, a communication relay satellite. It was first launched to a halo orbit near the Earth-Moon L2 point on May 2018. The robotic lander and U-2 rover were launched on 7 December 2018. Chime 4 lander from U-2. A weak landing, U-2 mapped this picture of the Chime 4 lander. Scientific objectives of Chime 4 and U-2 are to measure the chemical composition of lunar rocks and swirls, to measure lunar surface temperature over the duration of the mission, to carry out low-frequency radio astronomical observation and research, to study cosmic rays and to observe the solar corona. U-2 as seen from Chime 4 is shown in this picture. Lunar Reconnaissance Orbiter is a NASA robotic spacecraft currently orbiting the Moon in an eccentric polar mapping orbit and was launched on June 18, 2009. Artist's concept of NASA's Lunar Reconnaissance Orbiter is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Lunar Exploration Present Missions presented by Dr. Anshola Ogundele, with the focus points, present lunar exploration missions, and list of present lunar exploration missions. Thank you.